We think, when I say we, just the scientific community, physicists who concern themselves with the very early universe, cosmologists, that the laws of physics as we experience them are set in the very earliest stages of the universe. And quantum fluctuations in everything would be responsible for another universe having slightly different laws of physics than ours. Because the quantum fluctuations will take it in a slightly different law of physics direction than our universe. And this would just keep going. Every universe that's born, even if it started out sort of the same in the very first instant, a later instant when other laws of physics manifest, could be slightly different. When you take Einstein's general theory of relativity, the modern theory of gravity,
correct,
gives us our understanding of the Big Bang,
right,
and all this, all the modern cosmology. Then you have quantum physics, which came out, interestingly, 10 years after general relativity. This is now in the 1920s. Quantum physics is all about molecules and atoms and nuclei and particles. Okay, those two theories do not play nicely with each other in the sandbox.
Okay.
They each work in their own regimes, but you try to bring them together, they are inconsistent with each other.
Worlds colliding,
Worlds
Jerry.
colliding. It is figuratively that.
Right.
All right, so now, what happens at the beginning of the universe when the entire universe was the size of an atom? Whose rules are in charge?
Whoa.
You have a shotgun wedding.
There you go.
Between quantum physics and general relativity.
And, oh my God.
And all of us are pretty sure that quantum physics wins. And in so doing, quantum physics, where it pops particles in and out of existence, it could pop universes in and out of existence. Whole universes, if the universe is the size of a particle.
Absolutely.
So, the point is, let's go back in time when the whole universe was the size of a particle. What are the rules of quantum physics telling us? They're telling us that multiple universes could be popping in and out of existence. And we are just one of them.
Gotcha.
Each one with a slightly different law of physics.
Okay.
So, there's no limit on how many of these universes there could be. Let's say there's infinite.
Okay.
If there's an infinite, that means there's every possible combination of all particles there ever were.
Right.
Including combinations of particles with you on another universe, on a podcast where you have an evil mustache. Well, you already have a mustache.
I already have an
You have an evil goatee. Well, you already
have an evil goatee. Yeah.
Okay,
right.
There's the nice Chuck.
Right, I was going to say.
Clean-shaven
Chuck.
Nice Chuck in the other universe.
Right, and he's still a virgin, by the way.
So people like thinking about this as a means of immortality. However, why would this Chuck, with all your atoms in this way, have any consciousness overlap with the Chuck in the other universe?
None. There's
no reason
There's
to be.
no reason.
For me to think so, because
that Chuck's living his own best life.
Living his own best life.
Right.
You don't have overlapping consciousness with your twin.
No.
And they're in the same damn universe as you.
And if they're identical, they came from the exact same single cell.
Single cell.
Right.
So if you don't share consciousness.
Right.
With your twin, I'm not given reason to think you would share consciousness with somebody else who has the same molecular DNA construct as you, but in another
year. Right.
There you go. That's
so there you have it. So I mean, that makes perfect sense.
Yeah.
You know, that makes perfect sense.
To even ask what was around before the Big Bang would be like asking what is north of the North Pole?
What is north of the North Pole?
The question has no meaning.
There you go. Okay, so let me get this straight.
Yeah.
This singularity happens. Boom! A second later, everything else that is inside of that.
Yes.
So time and space, all of that is inside of this thing that now is in existence.
Yes. So that would mean that if space is nothing.
Oh, my head is hurting right now because I'm trying to think about
if you want space to be nothing, you need a word to describe where there is no space.
Wow, dude. We should call that nothing. What is around that singularity?
It's embedded in a higher dimension.
Right.
It's like if you're an ant crawling inside this sheet of paper and that's your world, you have no concept of what's above or below it, even though we do, because we're higher dimension.
Because you can lift the paper up and see underneath the paper.
I can see what's
while the ant is still on the paper.
Still inside
but
the paper.
But that ant can never see underneath that paper.
He can't see. No, the ant is in the paper.
Right, that's what I'm saying.
No, it's in the paper.
In the paper. He
can't
never
see above or below.
He can never see what's underneath it.
Correct.
That's crazy. So basically what we're talking about, this nothing, is really only resident in a higher dimension. at the time when the singularity.
Now, the higher dimension people might say it's embedded in this thing that they call something.
Right.
Even though if it's nothing to us.
Wow.
Yeah.
Wow.
Life is made of what we call organic ingredients.
Correct.
Those elements weren't around at the Big Bang.
Ooh.
They were manufactured in the cores of stars.
Nice.
Of a kind of star that happens to then re-release it out into space.
Sweet.
So you have to stockpile generations of these supernova explosions that have made these elements and enriched the galaxy. You have to stockpile generations of them so that a later gas cloud doesn't only have the hydrogen and helium it was endowed with at the Big Bang, it's got these extra contaminant enrichments. And out of those enrichments, the next generation of star systems will have the ingredients that can make planets and people.
That is really very...
And life in general.
I wish that was common knowledge, that what you just said right there is so important in terms of an origin story.
Yes.
It's so important.
It's our origin story.
It's our origin story.
Origin story of life.
Yeah.
Right.
Wow. Hey, man, that's a great question.
That's why if you're looking at very, very old stars in the galaxy, it's pointless to try to find planets with life on them. We think.
Right. Yeah. That makes sense.
Yeah. 5 billion years from now, where even more generations of stars have enriched, could those star systems have so much organic material that they'd be teeming with
life.
Like life on Earth, it has only one genesis, as far as we know. Yeah. Maybe there are planets with multiple genesises of life.
Like they can't, like they're just tripping over life.
Tripping over life.
So much material there to make life.
So much material to make life. Yeah.
Wow. Why is everything spherical and curvy in the universe? Spherical and curvy.
I wrote a whole essay on this.
Did you?
Called On Being Round.
Nice.
Multiple laws of physics conspire to make things round when you might want them some other shape. And that goes for soap bubbles. It goes for forming planets. It goes for forming stars. So the laws of physics conspire to make this happen, and that essay is an entire exposition on that. And you can just Google.
Dude, you are such a tease because you did not tell this guy why.
I think you can get the essay without having to buy the book. In the 1920s, quantum mechanics was invented, discovered, however you want to think scientific advances take place. Quantum mechanics is the study of the small, how particles behave. And we learned that if you get to a small enough scale, you lose the ability to predict with precision the behavior of the system. You can only describe it statistically. And there are ranges of things it can do, and all you can describe is the range of properties that it may have. Well, here's this big grand universe we have described by Einstein's general theory of relativity. But at the Big Bang, the entire universe was the size of an atom. And so you have the need to have the physics of the small, quantum mechanics, marry the physics of the large, general relativity, because they're occupying the same space. Now, when you take quantum mechanics and apply it to aspects of the fabric of space on that scale, what you have is a gurgling of the fabric of space-time. In fact, it's been called a quantum foam. And so now when you look at this foam, applying the laws of quantum mechanics to it, you realize that this fabric is not limited to one zone or another. In fact, there's a region of the fabric that could hatch out an entire universe with the variations in the laws of physics simply because the conditions that would spawn the laws of physics had variation in them. And so the multiverse is not just some invention out of the ether. It flows out of an application of quantum mechanics to general relativity.